Ready for the deep dive into Java decomposing applications and stuff like that. My name is Milen Dyankov. I'm a developer advocate at Liferay. And out of curiosity, how many of you have heard of Liferay? Okay, quite a few people. So this is my job as a developer advocate to typically go to events like this or meet people who use our products and talk to them and see how the stuff that we do helps them be more productive. And those of you who never heard of Liferay, or those of you who have heard of Liferay from like years ago, you may recall it as the portal company. And indeed, the roots of the company are in the portal business. But since then, things have changed a lot. We do now have lots of different things in a variety of spaces. You'll see a bunch of like front-end technologies, some tools. The main product is still the Liferay platform or the Liferay portal, depends on how you want to call it. And what we've been trying to do in the past several years is try to actually decompose that one big piece of a software into smaller pieces of software that are actually reusable and more helpful. And this talk is a little bit about that, but it's not going to dive into the details how we actually do it in the company. It's just going to give you some very basic overview. And I could also introduce myself as me. I'm a father of 3. How many of you are parents? Okay, quite a few people. So one thing that becomes immediately obvious when you become a parent is that the communication style that you have needs to adapt. So the second, like the sub or hidden title of this talk is cleaning and tidying children's rooms. And if you're a parent, if you have kids, you know how that works. You go to the kid and say, well, you know what, you need to tidy your room. And the kid looks at the room and says, well, what do you mean? It's tidy, it's clean and tidy, right? And then you say, no, it's not clean and tidy. And then how you tell your kid that the room is, what is it, a clean and tidy room? Well, you go and you show. You put stuff here, and you put stuff there, and then you say, well, this is tidy room. And then the kid learns by example. Next time it follows you. The question is, if it puts the toy here and not over there, is it still clean and tidy? Now, those are kind of the questions that we'll be dealing with. So I was trying to figure out a good way to introduce those concepts. And I thought of a Conway's law. How many of you are familiar with the Conway's law? Okay, for those of you who are not, it is basically a law that says that an organization that designs a system will inevitably produce a system whose structure will be a copy of the organization's communication structure. And this is what we often see in software. This is how people design software. They just, like take the stuff from the real life and put it into the software system. Okay, so let's reverse that. And this is where the idea for this talk comes from. It's like, okay, if that's true, then maybe we can flip it the other way around. Then it means that if you take any design of a software system, you can actually explain it or present it as an organizational communication chart. And this is what I'm going to be trying to use today in a couple of examples to show you how different ways of designing software systems can be applied and what they mean in practice and how things that we are looking at can be both, for someone can look like a very nice and clean, and for someone can look as a complete mess. So I'll be showing you diagrams like this. And then the example is very simple. We have our Harry, and Harry wants to start a business. So he's going to be providing cleaning services to people. So they call him, please clean my house, pay him some money. He goes, cleans the house, that's it. Now, that's a very simple use case. Now, let's implement this in the very simple possible way. So we have Harry. And Harry has a bunch of things. He has cleaning tools, supplies, he has his van that he drives, and so here is the business logic. The business logic is basically Okay, so this is the initialization. So he buys some tools in advance, and this is the clean house process. So Harry checks the money. If you pay him enough, that's okay. And then he grabs the cleaning tools. Basically, he goes through every single cleaning tool, figure out which ones needed. The same thing with the cleaning supplies. Then he loads all the stuff in his van. He sits there as a passenger or a driver, and then he drives to a given address. He cleans the house. He's done cleaning, packs the stuff back in the van, goes home. Then he checks the supplies, eventually reorder them because he's a proper businessman now. He needs to do some bookkeeping. Right? And that's pretty much how the clean process from Harry works. But Harry is also a person, right? He can, for example, borrow his van to someone, right? If a friend comes home and say, Harry, can I borrow your van? Sure he goes. Now, he checks if that's a friend, borrows the van. If not, then not. And the same thing with like borrowing tools and stuff like that. Now, for the purpose of demonstrating this and all the other examples that you will see later on, we also have a very simple client. A client is nothing special. It just starts a J-line, command line interface where we can issue comments and test stuff. So let's try that. So we are the first example. It's already compiled, but just to make it sure it all works. So let's package, let's clean, let's build that. And we have a script here, which we tell which Java version we want to, do you guys see down there? Maybe I should put it up there. So we have this script here, which also we need to say which Java version we run it with. And you'll see why this is important later on. So it starts our interface, and then a client can say, clean my house, and you see the process that's we just described. Then someone can say, hey, can I borrow your tools? Oh, and by the way, I'm a friend. And Harry borrows his tools, and this person happens to lose them. That's a problem for Harry, but at least it was a conscious decision for him to borrow his tools. Or you can say, borrow the van, and Harry say, well, sorry, but I don't know who you are, right? I don't borrow my van to pretty much anyone. That's a perfectly suitable, perfectly workable application. What is wrong with it? And I would even argue that is the best application writing style from the complexity perspective. Everything's in one class. If you want to change something, you know where it goes. That's Harry, right? Everything belongs to Harry, and if something needs to change, it's Harry that needs to change, right? It's simple. It's great. Well, then Harry decides to go and get someone to help him. So let's close this, get out of the way, and we go to the second example, in which case, Harry is still using the same, pretty much the same logic, except now he puts all the stuff in the garage. So you have the garage, and the garage is where he keeps the cleaning tools and the van and the stuff. And he also hired Ronald, and Ronald's going to do the front-end work. Like he's going to, get requests from customers and pass them to Harry, right? And it's pretty much the same situation here. So let's go there, and this is our second example. Should build it again, just so it shows it's real code. And then we can run it again. This time is the second example. So if you see, if we say there's a cleaning request now, well, you will see that it's actually Ronald that takes the request, and then he passes it to Harry. In this particular case, Harry also has invested in something that's called Smart Garage. Now, why is that? If you look into the garage code, you will see that the garage itself, it's such a magical thing that you can pass it some instructions, and it's only going to give you the tools that are needed, right? I don't know how artificial this sounds, but you will see in a second why is that. And this is how it looks like. So you have the client, calls Ronald, Ronald calls Harry, and Harry asks the garage, right? Now, there is another problem that shows up here because we've decomposed the application now. There is a possibility for Ronald to actually go grab the stuff from the garage and borrow it himself without Harry even knowing about it. And as a matter of fact, if we now try to borrow the van, for example, we'll see Ronald cannot do that. But then again, one day, Ronald's going to figure that out and say, oh, wait a minute, I can actually do that, right? And, wait a second, we need to organize imports here. Util list. Don't you love this, the list stuff? So let's build that thing again. Let's run it again. Wait a second. Okay, let's run it again. And now, let's say someone says, hey, Ronald, can you borrow the van? Sure, I can. Now, Harry doesn't even know about that because it was Ronald who was basically taking the van straight out of the garage. So we split this into two modules or libraries or whatever you want to call them, which kind of makes sense in terms of like this is single responsibility here and single responsibility there. And we introduced a problem that now Ronald can actually access stuff that he's not supposed to access. And if you actually, sorry, that's not yet this example. So how do you prevent that from happening? Well, you basically can't, right? Because now you could try to do stuff like this. You could try to go to your garage and say it's not public, right? And this is going to prevent Ronald from accessing it, and it's eventually is going to also prevent Harry from accessing the garage. Okay, so now this is a problem. Well, no, not even here. I'm sorry, because this is too early. You can do this like private, but then because Ronald and Harry are in the same space, in the same package, it doesn't really help. Both can still access the same thing. So then Harry comes to another idea, and he says, well, wait, let's do some more stuff here. And then we have now really split the whole thing into modules, and this is all those 3 modules. So now we have the assets module, and in the assets module, we have the garage, which holds the van, and the storage, which holds all the cleaning tools, right? And then we have the front office here, the front, and in here you have the Ronald and his order form, that they just talk to customers. And then in the middle, there is Harry. And he also got this guy, Andrei, who is now responsible for preparing the stuff for him. Like Harry says, Andrei, give me the supplies, and he figures it out. Okay, so it's a little bit a different way. It's like decomposing it in a little bit more, in a little bit different way. Let's see how that works. Okay, so we have the third example here. Clean again. Okay, and let's start it. So now, if we do clean, you see the process is pretty much the same. Ronald takes the order, Andrei is preparing the tools, right? And then Harry goes, grabs the van, goes, cleans the house. Pretty much the same thing. Works perfectly. Okay, so, but again, the same problem. Can someone borrow the tools from Harry without Harry knowing it? Well, eventually, Andrei is gonna, Ronald is gonna figure that out. And he says, oh, okay, wait a minute. I can actually do that. My favorite. Okay, so he has access to the garage and to the storage, and if we do this again, you will see that actually he can do stuff. Oh, wait a minute. What happened here? Cannot find van. Why is that? Didn't we do the import correctly? Oh, save. Okay. it helps to save classes. Okay, so let's do the same example again. Don't rush, still have time. So now, apart from the obvious cleaning thing, we can actually borrow stuff again, right? And this was not supposed to happen, right? That's why we isolated things, so that now we can have control of who has access to what. Why this is happening? Well, this is happening because all those things are now in a separate module, which is in this assets module here. And because they are in a separate place, and Harry and Andrei both are somewhere else, they both need to have access to these things, right? I mean, if you restrict access here to say, to the garage, and say, wait a minute, this is not going to be public, it's going to be private, you forbid Ronald to access it, but also Harry cannot access it, right? So there's whole kind of different issues in here. And this is this example. You have the customer, then you have something that you call the front, then you have the company module, which is supposed to talk to these two things, garage and storage. And Ronald is not supposed to talk to these things, but it's no way for you to prevent it from accessing them, right? As a matter of fact, this is the most popular software architecture ever, known as box cylinder. And if you look at any Java or whatever application written in the past 10 years, you will likely find that this is the exact pattern they all follow, box cylinder. Now you can call it front-end business logic database, or you can call it something else, DAO, or it doesn't matter. It's the same architecture that every application used to follow, and it was for many, many years presented as the best practices for building applications. Now, let's try to compose that application in a different way. Let's get all those out of the way now. So here we go. Close those. I'm getting lost in my Eclipse. Now, in this next example, we have pretty much the same thing. So we have the back office stuff. And now in the back office, we've put the storage, which is the same storage you saw before, and Andrei. So imagine that's a different building, and Andrei is already there, and he's keeping track of what's in the storage, right? Now, in this case, we can actually say the storage is package private, because this is restricted to the building. And the only way to get something from the storage is through Andrei. Now, the front office now is basically, again, only Ronald and his form. And the company, like the meat, the business logic, whatever you want to call it, is Harry and his garage, right? Because Harry still has very, good feelings about his van. Okay, let's build that and see how that helps. That's the fourth example, if I'm not mistaken. Right. Okay, let's run that again. And now, see, the procedure is the same. Ronald gets the order, Andrei prepares the stuff, Harry does the cleaning. Now, if we want to borrow the van, for example, there is no such way to do it. Now, if one day Ronald figures out, oh, wait a minute, I can actually do that, well, he actually can't. Because, and you will see it does not compile in here, and I can actually try to compile it from the command line just to prove it to you. Now it's going to say, nope, you don't have access to those things. Now, because those garage is now covered by Harry. The only way to get stuff from the garage is ask Harry, and the only way to get something from the storage is to ask Ronald. So if he actually wants to do that, he needs to go through Harry, and he needs to go through Andrei. Now, if he does that, we can actually make it work. But that is actually a good thing. Borrow van. Because now you see Harry here is responding, no, I'm not going to borrow the van because I don't know you. Right? So we actually structured the things in a different way. So we prevent these guys that don't need to access something from accessing it. Okay, and this is also well-known architectural design, which is this. The client calls the Ronald, and he calls Harry, and then Harry calls Andrei, and Ronald can call Andrei or can call Harry directly, but those are guardians, right? We actually covered those things that we care about, like the garage and the storage, behind the guardians. This is the universal microservices architecture, that's what I call it, right? And this is the point where the company, when it reaches this stage, people start thinking, oh, we should do microservices. Let's put like all these bugs in a separate JVM, put it in a Docker container, and orchestrate it with Kubernetes, and we're going to be like so much better. Not necessarily, but it is an architectural style. It just introduces different issues. So now, at this time, Harry comes to realize that the model that he's designed the company is actually not really representative of what a company should look like. And he starts looking around at more advanced companies to see how they are organized. And in this case, he realizes that if you look at the company internally actually has a structure. So the company has assets like storage and vehicles and stuff. And in this case, it's just the van. It also has job positions. And those job positions are abstract things. So in this case, it's interfaces. So we have an accountant, we have assistant, cleaner, and we don't know who that person is. We basically just know that we have such things, and someone is doing the actual thing. The company also has policies, like for example, pricing policy, and it also has processes. Like most big enough companies have processes. Like this is, for example, a clean house process, which basically says, well, send a cleaner. But there is also a prepare for cleaning process, which basically says, well, find me the cleaner and prepare some stuff and things like that. There is also stuff that needs to be shared between everyone in the company. Things like what are the instructions like between the processes? Like how do we go from one process to another and stuff like that? Or how do we handle situations where something goes wrong, and which reflects to exceptions? And then at the end, we have the staff. The staff is basically Andrei, who is an assistant, and Harry, who is a cleaner. But because he's also doing the accountant stuff, so he's also an accountant. And then now you can see how this decomposition allows you to actually fulfill different roles with the same thing. You can say this Harry is going to be taking these two positions at the same time, right? So this is the internal stuff of the company, right? But then, again, the front office has to be something more abstract. So we now have this in abstraction, which is the front office, and it just handles requests from the customers, gets the money and the stuff, and then it calls this thing called customer use cases. Okay, what are use cases? So use cases is basically how the company can be used? Like, what is it that you provide to the outside world, right? And in this case, we have a customer use cases. One use case is clean customer house, because this is what our company do. It cleans houses, right? And then this is the use case in which we use what's inside the company, internal processes, and basically say, well, first, there is a new order process, then you need to make sure the payment is correct and stuff like that. And then, from the new order process, you get the instructions, like someone's gonna prepare instructions, and then you get the supplies, the tools, then you prepare for cleaning, then you send the cleaner to the house, and then send them back, and this send them to the house and send them back is a transport process. And now this is the time when Harry came to realize that his van is actually not important. The important part is to actually be able to get from the company to the house that they needs to be cleaned and then get back. And how exactly that's going to happen is a secondary thing. And you will see how that kind of decomposition helps us further on. Okay. So we have split now things in a totally different ways, and we also had to change the client in this particular case. So instead of calling Harry or Ronald directly, as in the past, we now call this front office abstract thing, and it handles the situation. Well, let's try that. By the way, after the talk, I'm gonna make both the slides and the code available. The code is already on GitHub. I'm just gonna share the link. So you can play with this if you want to. Wait, clean package. Here we go. Now, let's run it. Actually. Right here. Okay, so, okay, now we change the process. We also require some money. So we'll say euro 100. And then it's pretty much the same process. But you see now, record income was before it was at the end, and now it's in the front. And this is because it doesn't really matter when you're going to do that, because now our process change. We record income as soon as we get it, as opposite to after we clean the house. But from the end customer perspective, it doesn't really matter. It's an internal process, right? So we have isolated our own internal mass from everyone outside. And this is keep falling. Okay. So what's going to happen in this case, if we try again to go to the front office this time and change the process? Some smart developer someday is going to figure that out, that, hey, here's a shortcut, so I can do that, right? And let's see what's going to happen here. Clean that again. Boom. So, borrow van. Boom. Why is this again working? Okay. So this is what we ended up doing. So we have the client, we have this abstract thing called front of office, and then we have the use cases, and we acknowledge the fact, by the way, the reason we did this is to make our company more flexible, to acknowledge the fact that in the future, there may be other channels to communicate with our company rather than the front office alone. Like, back to the software world, probably you're going to introduce some web services or something, or machine learning, or whatever comes in the next few years. So by doing this, you're saying, okay, there is going to be another ways of talking to us. But it doesn't change the use cases that we provide. We do provide clean house. Now, in the future, we may provide clean car or clean backyard or something else. We're going to introduce more use cases here as they come along. And none of this affects how our company is internally structured. Do we have what positions we have, what processes we have, what people do we hire? This is irrelevant for whoever is using our services, right? But because of this, because you've structured your company like this, now you have to make all this stuff accessible to the use cases layer, right? And because of that, all the use cases can actually go and talk directly to grab stuff like van or grab stuff from your storage and things like that. So you need to be able, apart from that, you need to be able to not only isolate classes, but isolate whole big portions of functionality from being accessible from outside. And with this approach, and in this environment, you cannot do that. But there is a way to do that, and that way was introduced in Java 9, and it's called JPMS. How many of you are familiar with JPMS, by the way? Java Platform Modular System, another way, AKA Jigsaw? Okay, not a lot. Okay, so this is the same, pretty much the same structure in here. The only difference in here is that we now split the packages. You will see about, okay, let me see if this makes it better. So you will see now that we have 3 packages in here that we've called internal. Right? And just by calling them internal, we don't change anything, but this is just a hint for developers that this is the stuff you shouldn't be using. It's internal for this module. Now, to ensure this stuff is internal, JPMS, Java Platform Modular System, brought us this new concept called modules. And module can export things. Now, in this case, we've declared a module called company, and we said that we export house cleaning company job positions, processes, and shared. So those are the things that outside world needs to know about. We also have assets, internal shared, and stuff, and those are the things that even though they're shared internally, outside world will never know about. And now we also say what other modules we require. We require some other things and some money and stuff like that. Now, if you look in the use cases, we have the same module info there, and we basically say, well, we do require this company module, again, things and money and stuff like that, and we do export these use cases. And if you look into the front office modular info will just say, yeah, I do export front office, and I do only use use cases. Right? So we are now repackaging the whole thing into modules that also have restrictions. Okay, I'm not going to have time to do the full demo, I guess, but try to go as much as I can. Now you'll see now that it compiles much slower. And the reason for that is because we now compile with Java 9, and we have the modular system in place. And while compiling, the modular system is actually enforcing those rules. So I'm not sure if you noticed, but the compile time for the whole project, which code base is it's identical code base wise, jumped from less than 2 seconds to over 7 seconds, just by introducing a modular system that ensures this consistency. So we can try to run this with Java 8 now, and it's going to tell us, well, sorry, but you've modularized your project, so you can't do this with Java 8 anymore. So with Java 9, you have 2 options. You can run it on a class path, and it works until some time. Sorry, need to provide the money again. And this is the tricky part here, because if someone now wants, if the front end now wants to be tricky, they can actually go and delete the module info file. Okay, I'll show you that in a second. Or you can run this on the module path. Okay, so this is the, sorry, Java 9 modules. Okay, this now, this now works on a modular path. And if I do borrow van, it's not going to work. Even if I try to compile this now, let's go out to our front end. Okay, here we go. Even if I try to add this, now, you will see here, if I try to compile this, come on, an exception during the during the compilation process. And it says, like for example, company internal access is not visible. So now the JPMS system basically says, yes, I know there is a package like this, but you're not allowed to access it, right? And I can even compile the code, not yet alone run it. If I want to be really smart, I can delete module info here and compile this with Java 9 on a class path, and the compiler is not going to compile, and then I can still access this when I do Java 9 on the class path, but it's a little bit of a more effort to actually get stuff done. And because we are getting really short of time, I need to move forward. So this is basically the same thing, except now we use the modular system of Java to basically say, well, hide those packages, all right? They're only for me internally, right? And now the problem with that, one of the problems with this is what's going to happen if the van breaks. So if you go to where it is, company processes, transport process. It's not here. Okay, the next thing. Okay, let's close this. Don't save. Now, the next example is basically the exact same thing, except what we've done is we also have split our processes. So if you look into the processes now, we have transport process as basically an interface. So we basically say there is something that I need to be able to go to the place and come back. And we have internal processes, like a transport process, which actually implements that. What this allows us to do is allows us to have more than one implementation of a given process. But the question now is, how do we get this? Well, in order to get this, we're going to use another Java feature, which actually was introduced at not package info, sorry, wrong module info, where it is, here it is, which was introduced in Java 6, but in Java 9 was moved to module info, and it's called service loader. And service loader basically allows you to do two things. You can say that you provide a service with a particular interface, and then when you consume a service, like for example in use cases, you can just say, well, I use this service. And that's basically the only difference that we have here, comparing to the previous example. And I think I'm going to stop it here, even though the most interesting example is the last one, obviously. But clean package. Okay, now that, again, takes a little bit longer. And just to show it works. So if you run with the Java 9 modular system and you say clean for some money. It's the same process, except it now uses services. And to demonstrate that, we have the transport process in here simulating a broken van. So is currently available is a function of the transport process, which says it checks a text file to see if the van is available. So I'll just go here in my 7 example, and in this file I'm gonna say, well, no, the van is broken. Okay, and if I do this again, we'll see we now have a different problem. We have a different way to go there, which is we order a Uber van. And we just don't use our van, we just use something else. How that happened? Well, that happened because we did have another module in here called Uber Transport, which also provides a transport process. And when we started our company, let me show this the run. We basically says, well, start the company, but also add the Uber Transport. So we now have 2 modules that provide us alternative implementation of the same service. And if something goes wrong with one service, then we can use another service. So if we now fix our van and run the same process again, you see that we don't use Uber anymore, we still go with our van. So we are able to actually change the implementation of the process as we need it to. Final example was supposed to be how this can be actually done dynamically with things like OSGI, but I don't think I have the time for that. So I'll skip that, but you will see it in the code. So this is the next way of decomposing stuff, is instead of having all the classes that you need to share public, you can still hide some of those and expose them as services in some abstraction service layer. And then whatever needs to consumes them from those service layer, regardless of who provides that. In this particular case, like the transport process, could be provided by our own company via our own van, or it could be provided by Uber because we sign up a deal with them, or it can be provided by a taxi company or whatever. And from the business perspective of your company, it doesn't really matter. It doesn't matter how, it matters to get there. Okay? So those are several ways to decompose applications. Why I'm showing it to you? Because I figured it out over the years that we have like there's a famous saying that there are 2 hard things in computer science: cache invalidation, naming things, and off by 1 error. I think the most important of this is naming things. And I think we've been terribly hurt by poorly naming things. So the moment you say clean architecture, reactive, microservices, agile, whatever, you name it, there's going to be a group of people who invented it and who put a meaning behind it. And there's going to be hundreds of groups of people who will then put their own meaning into that very same word. And then they're going to go around the world and tell you, no, that's not microservices. That's not how you do microservices. That's how you do microservices. And so we stuck to a name, but there is millions of implementations of what is behind that name. And so it's the same thing with telling your kids, clean your room. If I were a kid, my answer would be define clean, right? Clean means different thing. Clean and tidy for me is different than clean and tidy for someone else. So cleaning is the process of making the place safe and livable. And this is no different in code. When you decompose your applications, it's not because of you need to be agile or clean or whatever. It's because to make your code safe and livable place. Thank you. Do we still have time for questions, or 5 seconds? Okay. Do we have any of Nope. Everyone shocked as usual. All right, guys. I'll be here in the area, so if you have more questions, just find me. I'm happy to talk to you. Thank you again.